Good afternoon, everyone. Thanks for coming. Um, I'm José Carlos Chávez,
Hi, good afternoon, everyone. I'm Archita.
and we both work at Okta. I am a security software engineer, and she's my manager. So I have to do it good, right? It should be good, right? Today we are going to talk about end of life of software, right? Uh, but first, let's start with the milk before it expires, right? So milk, apparently 80% of the world population drinks milk, right? I couldn't check the numbers. There was no like a scientific like a source where you could appoint that information, but it's everywhere. So I guess it's true or not. But why people drink milk, right? This is a question that you can relate to. Well, there is a common knowledge that it has proteins, vitamins, minerals, and it has several health implications, right? If you Google it or check the reference about why people drink milk, it will be because it might do several things. There is no categorically affirmation about it, but it might help you with your diet. It might help you to fight diabetes. It might relieve cognitive impairment. But none of that is like categorically. But anyways, and because it's everywhere, right? Milk industry is huge, so a lot of advertisement everywhere about we should be drinking milk to be healthier, to be stronger, right? And because it's tasty. You can debate that, but it is a fact. So, let's say you open your fridge, and then you just discovered a container of milk that was shoved in the back of your fridge for a while. You don't know how long, and it's past the date stamped on the package, but it seems wasteful to throw it away, right? Because, we want to avoid food waste these days. So, will you drink it or not, right? That's the question. Before you make an informed decision, I would like you to understand what are the risks of drinking spoiled milk. Well, you can have some of these: abdominal pain, you can have nausea, you can have vomiting, you can have diarrhea. So before you drink it, you should take this in consideration. But often, even if you drink it and then you get sick, these symptoms will alleviate themselves within 12 to 24 hours if you receive proper hydration and if you stop drinking it, right? Otherwise, you will go through again the cycle of 12 to 24 hours. Luckily, spoiled milk smells, looks, and tastes like bad milk. So you get a big, let's say, a bit advice on not to drink in it, right? So you decide what you do. Let me open another fridge for you. And this is another fridge where you will find some spoiled things, like old packages, abandoned packages that are deep in your package log that nobody looks at, right? When you go and approve a pull request, click approve, you don't know what is in there in the package log. Even GitHub don't want to show this to you because this is mainly for machines, not for people. And then you might have a lot of past due packages and past due milk containers in here. So, will you drink that milk or not? Let me inform you again, so you make an informed decision. Well, if you use expired software, you will find compromised security, increased memory maintenance costs, lack of technical support because nobody maintains it anymore, compliance challenges, and incompatibility with current solutions, right? And for sure, these symptoms will not alleviate themselves, not in 20 or 12 to 24 hours, nor within a reasonable SLA, because you have to act here. It's not anymore like you have to hydrate yourself. So let me now hand to Archita, who will clarify how the AOL happens across the software lifecycle.
Thank you, JC. Wow. Yeah, so before we dive deep into the consequences of using end-of-life software, let's understand the different life cycle of a software. So when a vendor decides to work on a product, the first stable version, the release after working on the product, is what you call the launch of the product. In most cases, when the product is launched, it's available to a smaller set of customers, which they call early access. It's done with a purpose because it gives a window to vendor to work on any bug fixes, any important or significant feature that customer would like to have in their product, but they have missed it out. And this is a stage where you get lots of support from the customer because they want to gather all the feedback from this smaller set of customer base who have access to this specific version of the product. So once the early access period is over, then the product officially enters into general availability, which means it's available to a wider customer base, or basically open to everybody who wants to use the product. At this stage, you get all the support from the vendor, you get regular updates, you get new features, you get technical support for bug fixes, you get security patches and security issue alerts as well. Once the maintenance period is over, then the product enters into end of support period. There are many reasons why vendor move a specific version of the product from GA or maintenance to end of support. It works as a revenue model for them because more new features you make it available in a newer version. It's easy for them to do the contract renewal. The other reason is the amount of resource that they spend in maintaining the older version of the product. They can use that resource in creating a new version of the product that is more compatible with evolving technology. It comes with new feature. It doesn't have the architectural security flaws that the older version might have. At the end of support period, the support you get from the vendor is limited. You don't get any new updates, product updates. You don't get any new feature, but you might occasionally receive bug fix support, limited technical support, and security patch update. Some vendors, not all the vendors, they do offer extended end of support, and which is a paid support. So depending on the contracts that you have with the vendor, you get probably 6 to 12 months of time where you can get extended support in terms of bug fixes or limited technical support and support in addressing any security issue. But once the product crosses this period, then you officially enter into end of life. That means the product has been, or that specific version of the product has been completely abandoned by the vendor. You don't get any technical support, you don't get any new update, you don't get any security patch update, and it's increasingly risky for any organization to use a product beyond this point. So if this is very, very clear to you, let's move on to the risk associated with using the outdated software components. So like JC mentioned, there are many challenges using an outdated software, but we have called out some significant ones here. Of course, the first one being security risk. So there are broadly 3 types of security risk associated with outdated software. First one is, of course, the known risk, which we called known CVs or known vulnerabilities. Because outdated softwares are not maintained by the vendor, so it's an easy target for attackers, security researchers. They try to find security flaws with these outdated software versions, and then if it's a 0-day, they request for a CVE. If they get a CVE, then you know this version has a CVE. You know what is the security risk, you know whether there is a public exploit available or not, and in most of the cases, you might also know what is the solution for that, other than upgrading it. This is still better as compared to unknown risk. So when I say unknown risk, not all products or not all software gets this attention from security researchers. So let's say there is a software which has gone past end of life, it's not maintained by the vendor anymore, and it hasn't got any attention from security researchers or attackers. So it might look like an outdated component, but still very secure, but that might not be the case. So what happens if an attacker is targeting your specific organization, they're trying to get into your infrastructure or your network, and you're using an outdated software component? Probably that's the first time the software component is going to get attention of security researchers or a malicious attacker. If they find a security risk, you might not know in that scenario what is the security risk, what is the severity of it, how do you fix it, and how does it get exploited? Because that is the first time probably you and the rest of the world would know what is a security risk with the specific version of the software. And most of the data breaches we see, that happens mainly because of this unknown risk type with the outdated software components as compared to known risk type. Then there is a third category, which is compound risk. To make the outdated software run in your infrastructure, you also have to support an outdated OS or outdated platform where it's compatible to run. So what you're doing, you're already inheriting the risk of outdated software component, but along with that, you're compounding the risk by using outdated platform or outdated infrastructure that is supporting this outdated software component. Now, let's talk about non-compliance. Security and compliance goes hand in hand. Compliance is not always regulatory non-compliance, but it could also be vendor contractual non-compliance, it could be legal non-compliance. Regulatory non-compliance is very common and widely known, where most of the regulatory standards require you to have up-to-date components running in your organization. Most of the known regulatory compliance like PCI DSS, GDPR, or HIPAA, they require you to either use up-to-date software component, or they require you to fix all the known vulnerabilities by vendor-supplied patches. End-of-life software fails both the things. And failure to meet these requirements, A, will result in losing those certifications if you have already got it. B, it could result in severe financial fines. Like GDPR fines, I guess, around 20 million euros, which is a significant amount for any organization. Vendor contractual non-compliance happens. So most of the vendor and client contracts requires you to use minimum supported software versions in your infrastructure. And failure to do that could result in contractual obligation miss, SLA breach, and it could also result, if any incident happens, then you can't claim any cyber insurance because you're knowingly using something which you shouldn't have used. Legal risk happens when an organization is found to be using an outdated software component that resulted in an incident or data breach. So luckily or unluckily for executives, most of the time it's the executives who face these legal challenges. So depending on the country, the legal charges are different for knowingly using the outdated software component. Other than that, we have maintenance and operational issue. To keep using an outdated software component, massive amount of resource goes into maintaining it, making it run on the evolving technical platform. So, if I haven't scared you much, let's understand, knowing all the risks that comes with outdated software, why so many organizations still keep using it. So I'll pass it on to JC to walk you through that.
Yeah. So after that, what you said, I don't know why people still do that. But there are reasons, right? Because we all work for software companies and we want to release features, we want to make clients happy. And one of the biggest reasons is priorities, right? You plan for the year, you promise several features, you promise different new interactions, and yet you have to maintain security. as that is not necessarily something you can tie to revenue, right? So whenever you prepare the yearly budget and you plan for the year, you have to justify the work and link it to revenue. Security is not that fancy, so it's hard to do that. So priorities is one of them, features you commit with customers. Roadmap, because most of the teams have a roadmap to fit into the year, and then if security tickets are coming up, then that's outside of the scope. Even if you do, let's say, a budget, like 20% of the time we will dedicate to fix security tickets, that's not something you can foresee, how much time it will take, and how do you prioritize, like, is this critical? Even analyzing whether this is very critical, will this actually cause a huge impact in my platform, it's hard to plan ahead. Migration cost is another one, because let's say you depend on an outdated software that is end of life already, like migrating to new, depending on how far are you from latest version, is complicated, right? Because you might incur in breaking changes, you might incur in lack of documentation, you might incur in incompatibility with existing technologies. So this is another reason for keeping this expired software. Lack of awareness and ownership is another one. Like, I guess not every company is checking the EOL calendar every week. You don't even know where to look at, because there is no like a standard source where you can check, oh, this software is end of life. There are, like, AWS maintaining its own metrics, Mongo maintaining its own, right? But we also depend on a lot of open source projects that are maintained by volunteers or maintained by a single person. And I haven't been working in open source for a while. I haven't seen that all of them are doing end of life. Sometimes they don't even, sometimes the author already left the project and it's technically or it's factually end of life, but nobody knows. And ownership is another problem, because you may have different components in your organization, and some of them, after the 5 reorgs that you went through, you don't know who owns this or what. There was this piece running that has been working for a while and nobody remembers. Or you don't, when security comes and say, we need to upgrade this, oh, who this component belongs to, right? Nobody has touched this for a while. There wasn't any build in the last 2 years. So, and then one of the walls that we hit at security is definitely return of investment, right? Because again, you can, so from what Archita explained, there is no easy way to correlate the risk, because end-of-life software doesn't have an intrinsic risk, right? It's a possibility. You cannot assess that risk directly. Plus, you cannot connect that risk to revenue or to impact, right? You can say, oh, there is a reputation impact, there will be financial impact because maybe our stocks will drop, or we will have to postpone the entire quarter to fix the vulnerability or to fix the breach and all that. But there is no actual numbers that you can put over the table and say, this is very important, this is as important as this feature, this is as important as this customer needs. So that's another one. So that's why business keep using expired software, right? It's a different situation with the cheese, for example. When the cheese ages, everything it loses some humidity, so it gets drier, it gets more tasty. With software, it's the opposite. So now let me hand over Archita about organizations that got food poisoning.
Yeah, they really got food poisoning, and you never knew what was the food that poisoned them. So I've just taken some headline of the recent hacks that happened because of using end-of-life softwares or end-of-life devices. It might not be the sole reason, but it's one of the reasons why data breach happened or organizations got exposed to security risk. If anybody remembers LastPass hack, those data is being published in Pastebin. Later, they found out using outdated software component led to that massive data breach. And this is the type of unknown risk I was talking about previously. So most of the times when you see defense or healthcare sectors which are getting ransomware attacks or exposed to data breach, you never get to know what exactly was the security risk. Not many organizations publish their incident analysis report publicly. But yeah, one of the reasons that was given was for this healthcare security breach. They were using outdated components knowingly and ignoring the update. SonicWall was targeted by ransomware for using EOL devices. And at this corner, which might not be very well visible, sorry, I couldn't do a great job with that. So I have taken a screenshot of a research which is done by ChainGuard, where they're trying to show a software which went end of life in 2020. The risk of that software by 2024, the number of CVs attached to that software by 2024 went up to 2,000 or above, as compared to a software which went end of life in 2023 or 2024, for which the number of CVs still stay between 500 to 400. So it compounds every year. So if you keep using an outdated software, you are compounding the risk for yourself. The number of risks that you are inviting to your organization, it grows year by year. Right? The next one. And here, quickly, risk heat map for using end-of-life software industry-wise. So finance, healthcare, government, and defense are worst affected. There is no explanation needed why government and defense sectors are worst affected by end-of-life software breach, because yeah, I guess nobody cares about using up-to-date software. Okay, let's move on to the next one.
So let's talk about healthy software maintenance practices. Well, rule says it's fresh, it's good. But how fresh? Well, first you need to have effective management of your asset inventory for software, right? Because you cannot protect, you cannot secure what you don't know. So in a big organization, you can have several components deployed in different platforms, like different runtimes, different ways of building the software. So how do you track all that? How do you track the service you run in Kubernetes that you build on your own? How do you track the service that you pull from the open source version versus how do you track the one that you deploy in Heroku and Heroku manages the version? Like, all this is complicated, but you still have to find a way to keep track of the versions you use, to keep track of the versions of the let's say this bill of materials, for example, and all that must fit in an inventory, which can be your source of truth to determine what are you affected for and how to prioritize it. Something else you have to keep an eye on is the end-of-life calendars. It's a complicated task right now, and it's blur how will you track, how will you correlate the calendars with your actual software, because there are different ways something can be part of your software, right? It can be in the upper Docker layers, it can be in the package itself, it can be in the upstream library. So this is something you also have to do it manually, and right now there is no a standard process to do it, although you can aim some automations to keep an eye on that. Sources are also not clear, so you have to get information from here and there, and then rely on some vendors which actually go like manually across repositories and say this is end of life, the maintainer says version 2 is deprecated, blah blah. You need to implement regular updates and security patching routines. This is very important because the more frequent you update, the less painful it will be, right? Because you exercise the process all the time. There is a culture of upgrading. There is clear guidelines to test the change and all that. So the more you upgrade, even if it's not necessarily that you're in the urge of solving a security ticket, the better, because it creates a routine, it creates, or it gives visibility to who are the actors that will involve it. Like if you're part of a security team, for example, and you need to, you're promoting an upgrade for certain software, it's easier to pinpoint the actors. And then they will have already a process on how to upgrade, how to test this, how to release this, right? Because it's something that you will do frequently. Otherwise, it will be like a 2-3 weeks project because nobody knows how to test this change, who will affect this, or how am I deploying this, right? And embrace ownership is, of course, very important. Like, the more ownership, it's clearer for everyone who to talk with. Then those teams can plan ahead, like including to the roadmaps and all that. Now, Archita will tell you a bit more on how we solve this at Okta.
Before that, please forgive me about my artistic skills here. This is not very nice, but this is exactly how it started in Okta. When we were brainstorming, we just drew something, and I wanted to keep it original for this talk, so I just kept it like that. So before I walk you through like what is this, JC mentioned a very important point that why do organizations fail to use up-to-date software? And a very important point that he mentioned was ownership and awareness. Now, why there is a lack of awareness? Because whether you are a small organization or a big organization, you have so many applications, so many services. Every service, every application has different software component. It runs on a platform that has different set of software components. Every component has different end of life period because different vendor has different end of life cycle. And it's almost it's not practical for any product owner or any engineer or any engineering team to remember what is the scope of your asset and what is the tech stack for your entire asset set and when it is going end of life. Then he mentioned about ownership, like why ownership can be a problem. Ownership is not a problem, but the way we try to emphasize ownership, that is a problem. So in most of the organization, the way they try to solve this ownership issue is it's very people dependent. You expect the people to take the accountability of their asset, their tech stack, and where it's going end of life. But the biggest flaw in a people dependent process are the people, because people change. They move from one org to another org, one department to another department. So today they might be owning one product, but in next year they don't own the product anymore, so they have no idea about what technical component it uses now. We had the same problem with Okta. We had a very semi-automated process where we relied on end-of-life calendar. We relied on people to take ownership of checking that calendar and then updating, planning the update for the software components they use in their services and their application. But as expected, it didn't work well, and there were inconsistencies with how they're upgrading it. We ended up getting into situations where we had incidents because of this. So then we sat together and we didn't do anything out of the box. We created a requirement and then we checked what tools we currently use in the organization. And we tried to correlate whether these tools meet our requirement. And then based on that, we came up with this. Well, not exactly this. I haven't exactly mentioned the tools that we use in the organization for obvious reasons, but the overall architecture is something like this. So we used different data sources to get an idea about our services, our product, basically our assets, who owns this asset, and what software component these assets use. So I mentioned different data sources, but the one I've actually explained is the data source one, where we used a tool that the organization already used to catalog our services. So we use that as a source to list our services, who owns it, and what technology it uses. And for every information, we created an entity in a centralized cloud platform, and that's where we did the entity mapping as well. So for the name of the service, we created an entity. For the language it uses, we created an entity and the language version. And for the owner, like which team owns it, we created an entity. And in this centralized entity mapping cloud platform, we did the entity to relation mapping. So for service X that uses, let's say, Node.js 18, is owned by XYZ team. And for the language entity, we got the end of life information from a very nice website called endoflife.date. So this, so 90% of our end of life information comes from this website, but we also use other sources because this doesn't cover everything. Mostly for infrastructure components, it might not be a good source. Yes.
And we generate Jira tickets.
JC is just reminding me about time. All right. And then we used other data sources also and created similar entities in the centralized platform. And then based on the mapping we created there, we created Jira tickets for the respective teams. So this was a complete automated process, starting from gathering the information about our assets to create entity to creating Jira tickets. Now, when we started, our original architecture was to create tickets well in advance, at least 2 quarters in advance, to give engineering teams enough time to plan the upgrade. And just in case they can't plan the upgrade, then we can work on compensating controls to at least minimize the risk to some extent. But when we launched it, and we expected that also, that because we haven't been tracking it very well, there would be software components that are already outdated or going outdated in 2 days or 2 weeks or 2 months. So we created exception criteria for that. As an outcome, after a couple of quarters, we were able to give enough time to engineering teams to plan their upgrade. And the tickets landed with the right team instead of wrong owners. And we also got some unexpected outcome, which are, we found some resources that were just there consuming our money, but we were not using it, which was not the original plan of the automation. But after launching the automation, we found that as well. You can make it bigger, like we only included infrastructure and product components in the scope, but you can make it much bigger depending on what is your organization's need and where do you want to see your organization's security posture. Okay, now we move on to conclusions.
Yeah. So, well, as you might notice, security should be a first-class concern among engineering and the organization itself. It's very important that we involve, in a shift-left fashion, we involve security all across the software development lifecycle. That's important. And also when you build roadmaps and make decisions, planning. As I mentioned, upgrading often and early makes it a fluid process, makes it a frictionless process. So that's also very important. Actively monitor end of life of your components is also key on this, because otherwise you will not notice about it. Nobody's gonna knock your door and say like, I'm end of life. Well-defined ownership, as Archita explained, it's very important to plan and execute upgrades and give delegate tickets and also give accountability about them. And in this whole process, because all this sounds simple to explain, but it's hard to implement, hard to do. Like you deal with people, you deal with systems, you deal with PRs. So in the process, automate as much as possible, because it's going to be a lot of work. And then automations don't make mistakes, right? So yeah, thank you so much.
So just to add, be a partner to your, as security team, be a partner to your engineering teams, not the police. I think that's the way forward.
Yeah, we want to be security enablers, not gatekeepers. So thank you so much. If you have questions, we are happy to answer. Yeah.
You go back to this last piece. One more. Are you using SBOMs to know what components the services are using?
Do we use SBOMs? We do, but for most of the dependencies, you like JC mentioned that they don't announce end of life. But what you can do in that case, you can check which of the dependencies are not maintained for a long time.
Well, if I remember correctly, you were saying that, in that data mapping, you have like what components the service is using. So how do you establish what components the service is using?
You mean what a product is using?
What are the packages being used? Is your question? Yeah.
Yeah, I think we use a tool for product. We use Sneak that generates SBOM for us, but we don't track EOL for all of them because EOL might not be available for all of them.
And could you give me a mental model of how end-of-life.date works?
So end of life is just an API that you can consume where it will tell you this package.
But how is the data fed into it? How does it work?
How the data what?
The data, like a database of data, right?
They want to.
How does it work? I mean, where do they get the data?
Where are they making the
Oh.
data?
I think it's the announcement. So instead of you going to different vendors' official announcement, end of life.date collects it for you in one place.
Like for big things,
Yeah, it's mainly for official. That's why we were saying like they cover like for example Mongo is a good example. They publish their catalog for end of life, and then they scrap that data and put in their database. But it's
like a random NPM package.
so yeah. There is another tool that we. I don't know if we can reveal the name.
Yeah.
Well, with Socket, for example, Socket tells you like version 2 of this random npm package is out of date. Then that's good in one hand, but in the other hand, we have to double check that. We have to go find evidence that actually the maintainer said this package is version 2 should be deprecated, right?
Your team is doing that,
Yeah.
Yeah.
and you feed that information into a centralized.
Yeah.
Thank you.
But just to mention, Socket is not shipped left. It's not going to tell you when it's going end of life, but it can tell you whether a package is maintained or deprecated.
Yeah.
Yeah, I just wanted to add that the SCOMs they don't register what type of framework the system is using, right? So if I have C# code, it doesn't recognize
No.
the C#. So I built some additional stuff
Yeah.
to add it into my SCOM because Things is not finding it.
Yeah.
Yeah, for example, one case is as well like Python, for example. If you don't have a requirements.txt, no tool will guess what are the packages you're using, right? So tools help, and for compliance reasons, we need tools, but it's not necessarily that they do all the work for us. We have to do a lot of manual work as well. What I tell you, that we need to double check that socket report is correct. We need to double check that sneak, because sometimes they report a ticket, but then we don't necessarily using the ticket. It's a transitive dependency that we overridden, but the sneak didn't catch up. So there are a lot of complications around this. Otherwise, this will just work, right? Any other question?
What is the dependency level you are tracking in the database? Is it direct dependency or is it transitive dependency?
Mostly direct dependency, because transitive ones, for most of them, you don't get this pre-hand information when it's going end of life. The only thing you can do, the best thing you can do in that case is to check whether it's maintained or not. And you can define a timeline, like if there's been no commit in the for that library for, let's say, in last 1 year, 2 years. That's something you can define for your own organization.
But this affects your sheet also?
Yeah,
Yeah,
it does. It does. Unfortunately, yes, no, we haven't tackled that part yet, but we are still researching into that.
Yeah, the thing with transitive dependencies is that they are not as easy as direct dependencies to upgrade, right? Because some, for example, NPM packages, you could have package A as a direct dependency. You can have the same package in a different version as a transitive dependency. You can have the same package in a different version for another transitive dependency. So then chasing down, okay, what is the version of the upstream package that upgrades this? Then it's very complicated, or coordinating the overrides. So as of now, tracking the transitives are not something we aim because it's a lot of complications. But we're already having challenges with direct dependencies only. But definitely is in the plan for next cheese.
Do you have a view on how good your dependency coverage actually is? Because there are so many ways of pulling in dependencies, and you might miss some. You might actually have implicit dependencies that are not expressed in the dependency management system.
Sorry, okay. I couldn't hear the beginning and.
He's asking about the dependency coverage for a product.
And do you have an estimate of how good your dependency coverage is?
Yeah.
So.
It's easy to pull something in with a Git submodule, right? You don't take that into account the missing dependency.
Yeah, so one thing is we use, one language we use is Go, so you have clear what dependencies are you using. Then we have incorporated controls on CI to say you are adding a dependency that is, for example, under this risk in socket, for example, which is unmaintained dependency. That's one thing. Second thing, we use also Node, where you can have more complications, but we also do an effort to keep the package JSON clean and cover in build time, because we also own the pipeline. Like we have our own pipeline for building the projects that we have, and we include several checks around, oh yeah, we are actually pulling this dependency. I think we have some projects in Python, but they are mainly internal projects, so we don't, I guess we will have a lot of problems there, because requirements.txt is not something that is mandatory. Yeah, mainly Go and Node are languages in our side of the organization. And as I said, we included also CI checks. So whenever someone is pulling a dependency that is not healthy, let's say, it will show up. And we have also post-merge controls. So yeah, we try to include these checks across the software lifecycle. Okay, I think we ran out of time. Thank you so much.
Thank you, everyone.